All right, welcome guys, and to another session. And of course, it is Mathematics Talk Talk again, right here with you. And of course, on this video, we'll be talking about heat. Our discussion is actually around the topic heat, and we're going to be running this from the potential level to a very, very high level, right? Now, when we talk about heat, it has come a very, very long way, and there are a lot of questions surrounding heat. In fact, I will ask myself some basic questions like how does my refrigerator tend to cool what objects or things that are definitely put inside? And another question I would have loved to ask myself is how does steam engine? And far from that, you all have air conditions in your various houses and homes. How do the air condition tend to what? Tend to change or alter the temperature of the room? So all of that and more you're going to be seeing in this session. Now, talking about it in this case, right? Let us assume I have two objects right here, and there is object A. And of course, I have another object in this case, and that is object B. And in these two cases, of course, I am assuming right now that object A represented with the red hot because it is, of course, hot, and object B definitely not between hot and cold. I can call it cold. So I have my object A, which is definitely hot, and I have object B, which is somehow cold, right? Because there's a temperature difference between these two objects. Object A will transfer some energy to object B if they are brought close to each other. That is what we are saying in this sentence is that, right? If I have to bring object A closer to object B, object A will transfer uh, some of its hotness to object B. That is, object B will become hot, but not as well as object A. There will be like an in between division. That is what I'm saying in here is that they will have a kind of equilibrium, a kind of equilibrium temperature. And this equilibrium temperature is definitely what we refer to as a constant temperature in point A and point B. Now, temperature A, right, is definitely hot, and that temperature was transferred to B, right? For instance, we can think about this that if this have a temperature of 70 degrees Celsius, and that is for A, and this one have a temperature of, let's say, about 20 degrees Celsius. If I have to bring object A closer to object B in this manner, then what will happen is they are going to have an equilibrium temperature, which is definitely going to be maybe, of course, around 45 degrees Celsius. So the equilibrium temperature that both of them will share might be around 45 degrees Celsius. And therefore, we say that object A in this case have transferred some energy to object B. And this makes us understand, of course, that what heat, right, it's a form of energy on its own. So we call that the equilibrium temperature. And the equilibrium temperature here now is 45 degrees Celsius, like we said before. So let's move it to a stage B. Now let us assume in stage B, we have two objects here. And here is object A, and here is object. Now, these two objects actually, right, have the same temperature. They have the same temperature of about 30 degrees Celsius, 30 degrees Celsius. Now, since the temperature of the two of them is 30 degrees Celsius and 30 degrees Celsius, if we bring object A closer to object B, object A move closer to object B, there will not be transfer of energy. That is, the temperature of A remains 30 degrees Celsius and the temperature of B remains 30 degrees Celsius in this case. And of course, since there's no temperature difference, right, there will not be flow of energy. But in this case, there is a temperature difference and therefore there is a flow of heat energy. And this is a simple explanation of Zeroth's law of thermodynamics. So in this case, if we take our thermometer and we measure the heat energy of A, you notice it's 70 degrees Celsius, and then we measure the heat energy of B and it's 20 degrees Celsius. Since the temperature are not at equilibrium, therefore the flow and the heat will continue to flow until the equilibrium temperature obtained. But if the two temperatures are already in equilibrium, of course there will not be heat flow between A and B. So we refer to this as Zeroth's law of thermodynamics. Now, how do we measure the temperature between A and B? Now, to measure the temperature between A and B, now we use the object, an instrument, the instrument we use to measure the temperature is referred to as the thermometer. Now, the thermometer is an instrument which to measure the temperature or heat energy, change in heat energy between two objects. And of course, there's always transfer of energy, don't forget, whenever energy are not in equilibrium. But if the energy are in equilibrium, there won't be transfer of energy.